Hello and welcome to the program. Naseni Solar Energy Limited, a solar panel manufacturing company in Karachi, Abuja, is the first of its kind in West Africa and the second in Africa. It is equipped with the requisite machinery, manpower and the technical know-how to produce high-quality solar panels that have outperformed others in the international market. The company is one of Naseni's intervention moves towards providing alternative energy source for Nigeria. In today's edition of Naseni Milestones, we take you to Naseni Solar Energy Limited, Karachi, for a critical assessment of the company and its relevance to national development, especially in the area of renewable energy. My name is Kirian Umayo. It's good to have you on this edition of Naseni Milestones. Let's take you through the solar panel production process. And first is the scriber station, as the Managing Director Jafaru Mahmood explains.
We have two of these machines. These machines enable us to cut the cells into smaller sizes, so that when we put them together, what we call string soldering, they will give us a specific dimension that we want.
The next stage of production process is testing and sorting. This is where the cells are sorted and categorized according to the various parameters in line with the required versions.
When the cell comes, they come in parts. As we unpack those cells, we have to keep them here, because from the beginning we should have an idea of what we want it to be, the specific version that we want, whether 80 watts, 175, 200, 250 or 270, which is the highest that we are doing at the moment. From here we'll sort it. There are various parameters that make up a solar PV. So those different categories, we sort them. This machine assists us in sorting, differentiating or putting them into certain categories. Ahead, we are going to see why and the output and what brings that.
This is testing on certain stations. So what I do here is I test each cells. So if I test, after testing the cell, in rank it gave me here. If it is rank 5, I'll put that one by the side. If it gave me rank 6, I'll put that one in another side. I'll arrange it based by the rank at which it comes. And those rank came based on the parameter of the cells given. So that is what I did here.
Because some of the cells have different ranking. So because they have different ranking, and we need them, they have different parameters, we need them to go together. Because we already have a design and intention of what we want to produce at the end of the production process. So what it does is that it carries each cells, it snaps it, the parameters are translated, transferred to a computer and translated into figures. So he will be able to say these ones are these ones are these. So that those who are going to work on them will also work on them according to the way he has presented them.
The soldering station are in two areas. First is single negative soldering station, after which it is passed to the string soldering section, where the positive and negative are put together to form an array of the cells.
First is the single soldering station. What that means is that they are doing it singly, taking a single cell and adding something to it.
What we do here with our colleagues, we solder the negative side of the solar cells and then pass it through to the string soldering for further production of process.
So you solder it to a single cell.
Yeah.
You work in single.
Yes. The negative side of the solar cells, we solder the side and then pass it to string soldering where you want to join them together. Yeah.
This is the way the single solder cells comes. The single soldering was done on the negative side, which is this side. So what I do here is to now put this particular single solder cells together. Depending on the design, if you check here, you see that these cells are 10 that are stringed together. So depending on the design that is needed, we can either reduce this number or increase the number. And the connection that is done here is series connection. Series connection. And the reason is to increase the output voltage.
Next stage of the production process is the glass washing section, where any form of impurities in the glass are washed away for optimum results.
Because our production is in sizes, so we also need these materials to be cut into specific sizes so that they can align properly. For example, when we got to the main station, we saw that the same size of the TPT was the same size of the EVA, and now the same size of the glass. So it is in this station that we cut the TPT and the EVA according to the size. If we are producing another size, we also change it to the other side.
The laying and continuity section is here explained by the managing director.
This is the laying and continuity section. At the beginning, we saw the negative, we saw the positive. And from here, they are going to put everything together. That addition that they did from single to multiple, they will bring it here. But here, you are seeing other things. The glass comes in here also. And we have the TPT, what we call the encapsulating material. We have the EVA, the terminal acetate, and we have the TPT, what some call the backsheet. These are meant to encapsulate the cells such that against environmental interventions or variations, so that there will be consistency in the solar PV upon complete production. So what are you doing here?
This is a main section. So the already string cells brought from the string soldering have been laid here over the glass. And when it is being laid, we'll try to do the connection to bring out the terminals, and these are the terminals here. And at this junction, we'll test for continuity on this table. And also the test for the wattage, the number of wattage that it brings out. Put on that light for me.
As part of the continuous quality control activity that we do in our production process, we ensure that at every stage we test the quality, if it's going to align with what we are anticipating at the end. If there's any problem, it is moved back. But if it passes, they document it as crossed this stage. So it moves on to the next stage. So here we now have the glass, we have the solar cells, we have the TPT, we have the EVA. So that is what we have here. Then the continuity, once it passes this stage, we are sure. At this point, we have a complete assembly. But there are other processes that are required to be able to move it to say, okay, yes, this is a complete solar PV, and this is the value that we are attaching to.
Lamination section is here explained by the managing director.
And when it is brought here, this is the laminating section. It is meant so that that is the assembly there. It is meant so that the whole assembly, bubbles or whatever that are associated with it during the course of laying it together will be removed, so that it becomes both water and airtight. And by that, it will to withstand certain climatic conditions. It is anticipated by the quality of what we're doing and testing procedures that this assembly is going to take 25 years. It's going to last 25 years. So there are lots of precautions that are put into it. So this machine takes it, gives some the number of minutes, then it will be completely laminated. A laminating machine, just like the one that we've just seen, but it is one of the most modern machines in the world. We procured this because we wanted to improve on our sizes, improve on our quality, and still remain competitive with any other product anybody can do anywhere else in the world.
After lamination, the solar panel is taken to the framing section.
a module that was brought in from the lamination machine, we will have to put frame so that it will be handy. A non-professional person, anybody will be able to carry it and it will be safe. Then after putting the frame in, then we will now put junction box. Is this junction box that will be connected to the terminal at the back? These are the terminals at the back of the panel. So the junction box will be connected to this place, to this terminal, so that any installer that wants to install, a very easy way to install.
So here they put the frame and they adjust it so that automatically they are locks, so that it will not be easy to disengage. And here also, in the course of putting that assembly together, we put certain features to ensure that we'll be able to identify our panels anytime we see our panel. So you can look at it. This is the logo of Naseni, which shows that it was produced by Naseni Solar Energy Limited. And here you have the flag of Nigeria. You also have Naseni written on it.
Simulation is a very important aspect of solar panel production because it has to do with the quality control.
This is the final stage of our quality control. Because the model we operate here, our quality control model is both continuous and terminal. At the end, we still check whether all those measures that we are putting together, whether they still give us the kind of result that we're expecting at the end. This, we have two simulating machines. One, this is the older model, what we call the darkroom model. We have the most current one. But here, what happens is that the conditions of this room is simulated. It's simulating the natural environment. Like I mentioned to you, the solar panel is expected to last for 25 years before it even starts degrading. So you have to simulate and try to test, do a kind of accelerated testing to be able to predict that it can do that. This is the second simulator we have, which is the most modern currently in the market. The operations or the objective is as the same as the other one, to be able to generate parameters from solar PV. But the difference here is that speed, this one is faster, and secondly, you don't need an enclosure, a complete enclosure, to be able to use this. You place the panel on it, it operates almost like a photocopier. The lights run through the solar PV and the parameters are generated. Again, they are transmitted into the computer and they are translated in graphical form, and the parameters are also stated. Again, for each of the solar panels, you have a distinct value that is printed out with it, and here is a sample of what you get. When we finish the simulation process, we are now sure that the quality is in line with what we anticipated from the very beginning, right from the raw materials warehouse. Then we now bring it to the finished products warehouse. This is the finished products warehouse. Here we have them, this is 80 watts. This is 80 watts. We have 190, we have 250, we have 270 watts. There is 175 watts.
In the solar energy value chain, installation, maintenance, and generation of data are very crucial. And at Naseni Solar Energy Limited, an apparatus and method of solar panel tuner was developed.
Also, it can be used for basic electricity. Yeah, because whatever you have in your house is here. Everything you have in your house is here. System design that you now move on to being able to translate the energy in the sun to the load that the people use, and it is that knowledge also you will be able to maintain.
This is a data center, as my MD has earlier said. In this data center, we have daily solar irradiation that we take using the pyranometer. We have two pyranometers. We have the mobile one. When we are on site, we take that to know the differences and compare. Then here we have the stationary one. It's permanently up and it takes the data daily. And this is the graph, as you can see. It shows the average daily insolation that you have for Abuja and by translation for the North Central. So as you can see, this is from January to December. This is the solar irradiation for January, which goes up in February, a little down in March, and when the rain comes deeper, it dips up till August, as you can see, and comes up again by September, October, towards December. So this shows the average daily, and this is the monthly that you have, the total energy that you have monthly from the sun. And these are the minimum and the maximum, the graphical representation. So these are taken daily.
From all indications, the Naseni Solar Energy Company manufactures quality solar panels of various categories which are recommended for use at homes, offices and factories for uninterrupted power supply. Here is the Executive Vice Chairman of Naseni, Professor M.S. Haruna, to throw more light on the vision and mission of the company, which has set the pace in indigenous manufacturing of solar panels in Nigeria. Managing Director of the company, Engineer Dr. Jafaru Mahmood, also commented on the company's capacity and capabilities in the manufacture of solar panels.
Our celebration past is that Karishi today is a limited liability company producing quality solar modules and other solar products that competes everywhere. And sometimes, I think in January, there is a product of which we produce in Karishi in collaboration of the African Association of Deans of Engineering Institution, in which we presented this in Spain. And that was an innovative product that was asked to be adopted. As a result of the coronavirus, we have seen that so many rural areas have suffered, because when they were online lining, they don't have power. They don't have, where they have power, they may not have internet connectivity. So we developed a portable equipment that combines both power and internet facility using SIM and with cloud extension, so that even where GSM network has not covered, they will receive signal there and be able to. So it was, appreciated and adopted for not only for the African region, but also for Caribbean. That is one of the success stories of Karishi. Now, it is a proof of concept from the beginning. We have been doing manually, trying to assemble solar cells manually and demonstrate in the laboratory how solar lights, how solar power can be generated. So we moved further to the actual equipment as a proof of concept. When we wanted private sector to come and invest and get this across so that it will be a product, no one was coming. So we moved further. Why don't we do it commercial and got government approval for a limited liability company doing all the business, so that this model, this demonstration plan, any private sector can come and see the performance of this industry and ask to be replicated. One good thing about Karishi, we did not go to anywhere and say, let's buy machines. That's why you see the production, one aspect differently, one aspect differently. In fact, the laminators, except the recent one that we brought now, the older ones, we fabricated them locally. That's why you see everything. Anywhere in the world, you go and see solar manufacturing facility, solar module manufacturing. You see, it's a seal complete system where you cannot identify one unit from the other. So we are proud of that because you can say that is it's truly Nigerians' ingenuity, and you can see everybody is trying their. Now, if we are to replicate that elsewhere in the country or expanding this, we now have experience, we now have exposure. We have built critical mass of able young men who have seen how it is done even in other parts of the world, brought this experience with them to move further. It is a limited liability company, generating revenue for the government and providing training for Nigeria. Not only that, we do the best installation and maintenance across the nation. Our installations are all over the places. We are proving to Nigerians and even the West African region that solar energy is not a myth, it's a reality. It is failing because of lack of capacity. If you do it properly, it's something that can serve you 30 to 40 years. The only thing you will be changing, if you are using the DC directly, you have no problem. But if you are converting it to ESC to use it at night and when there is no solar energy supply, then that means you need batteries to store the energy. So it is batteries that have lifespan. When they expire, you replace.
First solar panel was produced in 2011. But Naseni saw that investors were still very reluctant to come forward. So the present executive vice chairman said, okay, of course he had a background in the private sector. So since it is like this, let us run it as a company, so that people will see the numbers, see the processes, and it will be, it's going to make them believe easily that this thing can work here in Nigeria. That was already incorporation of Naseni Solar Energy Limited in 2013. The company actually started far earlier than that. So now, when I'm giving you a resounding yes, even where there are certain challenges like patronage, is that it has been done. It was started in 2013. Government, for the regular maintenance of this place, government has not spent a cover. It was to generate here that we used to maintain it, which is not on budget. We don't have overhead. So from that aspect, I will tell you, yes. Two, what we are producing here, is it the quality, is it comparable? Yes. As far as Nigeria will beat ourselves, that our products are the best. Because one of the things that is with solar is that it is a location-dependent thing. What you produce in a different environment, you bring here, what we produce here can beat it. Because we produce it right here in this environment. So it has achieved that. We've been able to produce solar panel. Initially, it was 100% importation. But now we have gradually started introducing indigenous things into it. Of course, I'm sure when you went down, you saw the manpower itself is 100%. But we are talking about the materials for the production itself. It's not 100%. There are a few things we do locally here to be able to add to it. And the idea was to move it from 0% to 100% indigenous content.
Science, technology, and innovation hold the key to the progress and development of any nation. In Nigeria, the National Agency for Science and Engineering Infrastructure, Naseni, is the catalyst for a paradigm shift from the utilization of conventional manufacturing technologies to advanced manufacturing technologies. Through its development institutes across the nation, Naseni is involved in the areas of reverse engineering, nanotechnology, advanced class content, education tools, agricultural equipment, and pioneering projects in the manufacture of solar plant modules, electrical and electronic products, multi-purpose machinery, and lots more. Join us on Naseni Milestones and learn more about nurturing an appropriate and dynamic science and engineering infrastructure base for achieving home-initiated and home-sustained industrialization for Nigeria. Naseni, creating enabling environment for local mass production of standard parts goods and services required for Nigeria's technological achievement. That's our program for today. We thank you for watching, and let's do this again next week on Naseni Milestones, the giant strides of the agency geared towards national development. I am Kirian Umayo. Thank you for watching.